Picture this. You are sitting in the exam hall. The clock on the wall is ticking down, the silence in the room is literally deafening, and you turn the page to find a massive, intimidating 12-mark question on artificial neural networks staring right back at you. This is a real scenario, straight out of a Cambridge computer science past paper, specifically question code 9713. Deadline pressure is a very, very real thing, and how you react in that exact panic-inducing moment, well, that determines your final grade. Today, we are going to break down the story, which is the exam question, and deliver the headline, which is your flawless maximum mark answer. Let's look at two typical students we all know. We'll call them Alex and Sam. When the pressure hits, Alex completely panics and goes into information overload. Alex dumps raw computer science facts onto the page without any real analysis or structure. There's no method, just a massive wall of text hoping something sticks. Sam, on the other hand, is a speed demon. Sam looks at the clock, rushes, speed reads the question, and completely misses the command word requirements. Sam writes a beautifully structured answer, but for the completely wrong question. If we were to look at their exam papers side by side right now, you'd just see a sea of red pad marks. Ouch. But listen to me, we are going to change that for you today. This explainer serves as your absolute insider playbook. We are breaking down exactly what the examiners are desperately looking for when that deadline pressure is on. You know, I have spent countless hours analyzing the Cambridge Principal Examiner reports. We're talking syllabus codes 0417, 0478, 0983, 0984, 2210, and especially our main focus today, the 9618 syllabus. And the verdict? It's always exactly the same. Candidates are just throwing away easy marks left and right. And it's not because they don't know the content. It's because they don't know how to play the game. The examiners are practically begging you to follow a specific structure. They want to see systematic analysis. They want to see evidence-based reasoning. When Alex writes a literal novel about the biological history of neural networks, the examiner just sighs, shakes their head, and reaches for that red pen. When Sam gives a brief, one-sentence answer to a high-value evaluate question, it's an automatic, painful loss of higher-order marks. But you are not going to make those mistakes. By the end of this session, you are going to have the exact blueprint to turn those red examiner marks into bright green check marks. All right, here is our highly structured blueprint for today's explainer. We're starting with the core concepts, moving into the procedural framework, unpacking critical examiner warnings, and finishing strong with high-scoring evaluation strategies. Let's jump straight into Section 1, Core Concepts and Connections, and see how this builds our absolute foundation. Before we continue, subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, so to stop writing like Alex and Sam, you need to deeply understand the command words. Top-tier students use what we call the PEAL framework: point, evidence, explanation, and link. Now, what's really interesting about this slide is that the principal examiner reports reveal candidates consistently confuse key terminology. So, rule number 1, you must always define your terms first. If the question asks about an artificial neural network, your very first sentence, your point, must be a crystal clear definition. An AN is a conceptual machine learning framework, but you can't just drop that and run. You must provide the evidence and the explanation. You explain that it draws on principles of systematic analysis, processing inputs through hidden layers, using weighted connections to actually produce an output. And finally, you link it directly back to whatever specific scenario was provided in the exam prompt. Let's do a quick test. I am giving you exactly 30 seconds. Look closely at how you'd apply this. Which approach is actively following the PEAL framework? Is it listing 5 random facts about nodes? Or is it stating a core principle, explaining how the data flows through the entire network, and then linking it directly back to, say, the self-driving car scenario in the prompt? The timer is ticking. If you went with the second approach, boom, you are already thinking exactly like a top-tier candidate. Let's take a little deeper into this. Candidates who explicitly reference cross-topic connections achieve significantly higher marks. Why? Because it proves to the examiner that you have integrated this knowledge with other areas of the syllabus. The theoretical architecture of artificial neural networks doesn't just exist in a vacuum. It's like a giant puzzle. When you identify causal relationships, like explicitly stating how adjusting the weights during backpropagation directly reduces the error rate, you are showing deep fundamental comprehension. When you form cross-topic connections, maybe linking neural network data structures to arrays or memory management concepts you learned elsewhere in the 9618 syllabus, man, the examiner's eyes just light up. This is evidence-based reasoning in action. You aren't just reciting a textbook from memory, you are actively manipulating the knowledge. This right here, this is the literal difference between sitting at a C grade and securing that A star. Moving on to Section 2, the procedural framework. This is where we turn theory into a repeatable machine. So, The crucial point we need to master is this method mark strategy. This is a standardized, repeatable sequence where marks are heavily, and I mean heavily, awarded for your systematic process, not just your final answer. Let's bring our friends Alex and Sam back into the picture. We are going to put 60 seconds on our visual timer, and we are going to rewrite their flawed answers live using these 5 exact steps. Ready? Step 1. Deconstruct the question. We isolate the command word and the subject immediately. Step 2. Extract relevant data. We pull the specific numbers, conditions, or scenarios straight from the text. Step 3. Select the analytical framework. For ANNs, maybe you need the Ford's propagation formula, or maybe you're calculating the error delta. Step 4. Execute with clear notation. Guys, this is absolutely massive. Even if your final calculation goes completely sideways under pressure, executing with clear working and proper notation secures you those precious method marks. Step 5. Present with correct terminology. Watch as the red pen marks on Alex and Sam's papers mentally transform into green check marks. By simply organizing their scattered, raw knowledge into this rigid 5-step sequence, they have gone from losing easy points to absolutely securing the bag. This sequence is your ultimate computer science success blueprint.
Practical application develops your core programming skills, requiring you to fluidly move through design, implementation, testing, and evaluation. This flow brilliantly illustrates the complete lifecycle of a computer science problem. Think about it. When you are asked to design an algorithm for a complex neural network task, you don't just wildly jump into writing code. Actually, scratch that. That's exactly what Sam does, and it's why Sam loses marks. You design it logically first. Then you implement the solution using robust programming structures. Next, you test thoroughly, which, by the way, brings us to one of the biggest examiner traps we will discuss in just a moment. And finally, you evaluate the performance. Does the network actually learn? Is the error rate actually decreasing over time? You have to document this entire life cycle clearly on your exam paper to hit the top band of marks.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to Ace the Exams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let's get right into Section 3, Critical Examiner Warnings. We rigorously search the Cambridge Principal Examiner reports, and these right here are the top 3 classic traps that literally rob students of their easy marks every single year. All right, sleeves up, we're moving into the interactive workshop phase. Challenge 1, the data scan. Imagine you are looking at a complex computer science data table. It's showing the training epochs and the corresponding error rates of a newly designed neural network. I am putting 60 seconds on the visual countdown timer right now. Your job, under pressure, is to extract the core trend. Look at the numbers in your head. What happens to the error rate as the epochs increase from 10 to 20 to 50? Does it plateau? Does it spike back up? Time is up. If you identify that the network actually began overfitting after epoch 50 because the error on the validation set started rising, you successfully avoided the first major trap, applying the right analytical context. But what about that second trap, forgetting boundary conditions and edge cases? Listen, when testing your algorithms on paper, if you don't explicitly mention what happens at the extreme limits of your inputs, like an import value of exactly 0 or processing a negative weight when the system only expects positive ones, you will drop marks instantly. Examiners are hunting for those edge case checks. And this slide brilliantly illustrates exactly why your answers must always be rigorously tied to the specific context given in the exam question. It's time for Challenge 2, Find the Flaw. I'm going to read you a flawed sample computer science paragraph written by our rushing friend Sam. Listen carefully. An artificial neural network uses nodes and weights to process data. It learns by adjusting the weights to lower the error. Okay, so where is the fatal flaw? Why does this perfectly true statement lose marks? I'll give you a hint. It is a completely generic response. The official examiner commentary for this exact type of answer states, and I quote, "Candidate provided factual recall but failed to apply it to the medical diagnosis system described in the STEM." To fix this and get the marks, you must write a contextual answer. It should sound like this. In the medical diagnosis system, the patient's symptoms act as inputs to the neural network nodes. The network adjusts its weights during training on historical patient data to specifically reduce the error in predicting the correct disease. Do you see the massive difference there? Context isn't just a suggestion. Context is everything. So, you might be wondering, how do we encode all these rules to avoid completely blanking under exam pressure?
The best memory hack is to use a visual story method to encode these concepts, ensuring you never ever forget your boundary conditions or your edge cases. Welcome to Challenge 3, Speed Writing. I am putting exactly 30 seconds on the timer right now. I want you to mentally draft one perfect Peel paragraph explaining how to test a neural network, and you must include a visual story element for a boundary condition. Imagine the data flowing through the network like a rushing river hitting a massive dam. That dam represents your boundary condition. Go. Keep drafting in your head. Remember your point, your evidence, your explanation, and your link. Make it deeply contextual to the river and the dam. And stop. If you manage to structure your thoughts clearly under that artificial 30-second deadline pressure, you are training your brain perfectly for the real exam environment. That's how you win. Okay, let's dive into our final section, high-scoring evaluation strategies. This is where we secure the top grades.
This final procedural system focuses strictly on satisfying those incredibly difficult higher-order assessment objectives. Problem-solving requires you to use a continuous deconstruct, solve, evaluate loop to systematically check for reasonableness and compare alternative approaches. These higher-order skills are where the A-star candidates completely separate themselves from the rest of the pack. When you are asked to evaluate a neural network's performance, you start by identifying the given information. Then, you break the complex scenario into logical steps. You solve it systematically, making sure to show every single piece of working out to secure those method marks. Then, and this is absolutely crucial, you check for reasonableness. Does an error rate calculation of 150% make logical sense in this context? No, of course not. If your algorithm outputs something unreasonable, state it clearly to the examiner and explain why it's wrong. Finally, you make justified recommendations. Don't just generically write, use a different network. You need to say, implement a recurrent neural network, because the context involves sequential time series data, which a standard feed-forward network cannot handle efficiently. That is how you demonstrate mastery.
Now, what's really interesting about this next point is how many students lose marks on simple compare questions. To score perfectly in comparative analysis, you must identify both similarities and differences, using explicit comparative connectives supported by evidence. If an exam question asks you to compare an artificial neural network with a traditional expert system, and you only write about how they both process data to reach a conclusion, you are providing a fundamentally incomplete analysis. You have literally locked yourself out of half the available marks for that question. Maximum marks demand that you use powerful comparative connectives like whereas, conversely, or on the other hand. You might write something like, both systems aim to solve complex problems based on input data. However, whereas an expert system relies on rigid, hard-coded rules from human experts, an artificial neural network autonomously learns and continuously adjusts its own weights through training. That right there is a top-tier, evidence-backed comparative analysis that examiners love to see.
So, the crucial point to take away from this explainer is to set your theoretical foundation clearly before launching into complex analysis. This warning comes directly from the principal examiner reports. Do not ever assume the examiner knows what you mean. You have to prove it to them on the page. Before we finish up, I want you to remember the 3 unbreakable rules that guarantee top marks. First, command word decoding. Make absolutely sure you answer the specific question being asked. Don't be a Sam. Second, Peel framework application. Structure your paragraphs logically with points, evidence, explanation, and deep context. And third, the time management matrix. Allocate your time strictly based on the marks available for the question, ensuring you have enough time left for that crucial deconstruct, solve, evaluate loop on the massive, high-value questions.
Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at AceTheExams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @AceTheExams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here. And as you close this out, I want you to ask yourself one final question. When that massive 12-mark neural network question appears on your final exam, are you going to panic and freeze like Alex, or are you going to execute this exact blueprint like a top-tier strategist?